Hello, this is Mr. Kramer's video lesson. Today I'm excited because we're going to do two new topics that build perfectly on what we've been doing. The first topic is parallel lines. A lot of us have a really basic understanding of it. It's two lines that are going in the same direction. If you ever see two lines where there's like a single arrow, it means those lines are parallel. If you ever see them with two arrows, so they both have two arrows, that again means those are parallel. Perpendicular are two lines that meet and make a perfect corner. So a perfect corner is 90 degrees. So in this situation, these two lines meet and you've got four perfect corners. Mathematicians, again, are lazy. They can't write two numbers, 90. Instead, they do a little box. So you see a box, it means 90 degrees. It means those two lines are perpendicular. So again, success begins at the start. Let's commit to 10 minutes. No distractions. Focus on learning. Focus on thinking. Deep breath. Okay. So, in the first part of our lesson, we're going to start with three equations, and all we're going to do is graph them. And I'm going to tell you right away, these are all parallel. So if I say they're parallel, what can we say about them? Well, the first thing is, remember, this first part is where we start. How do we graph these? We start with a 1, we put a dot there. We put this on the y-axis, a 1, and then we do the slope. The slope is 2/3. So that means we go to the right 3, 1, 2, 3. We go up 2, 1, 2, put a dot there. Get your ruler. Draw a straight line. You can even say draw a straight line the same way. Now if you look at equation B, our start is 4. So now we go 1, 2, 3, 4. Okay, there's our start. But now something neat. The slope is 2/3. So we again go. The right is the bottom number, 1, 2, 3. We go up 2, 1, 2, and we draw a straight line. And then our third equation, 2/3 x minus 3, -3. We go down 1, 2, 3. We put a dot there. But now our slope is the same, 1, 2, 3, 1, 2. We draw a dot. You draw a straight line. Now, what can you say about parallel lines? If we look specifically at the equation, they have the same slope. So this is a really important detail, because when you look at a line and someone says, are they parallel? You just look here, you just look there and say, hey, are those the same? Yep, then they're parallel. So if you go back to our diagram, we can add a little arrow there to each one of them. Because although I may not have drawn them perfectly parallel, that arrow means they are parallel. Well, let's take a look down here. We've got a whole series of equations, and let's just say which two equations are parallel. Well, you look over here and, oh, they switched the numbers around. So let's see, is there another slope of 3? Negative. Oh, right over there. So A and F are parallel. Well, who else is there? Let's see, is there -2? -2. Oh, wait, over there. So C and H. And notice how we had -2x first in H, and we had rearranged it in C. That's okay, because you know the slope is always with the x. The slope is next to the x. Well, let's see. 0.5x. I don't see 0.5x anywhere, but you got to think. It has the same value. So look over here. 0.5 and half, 0.5 and half. 1/2 equals 0.5. So that's the same slope. So E and D are parallel. And then lastly, G, 5x, 5x, yep. B and G are parallel. So look for the same slope, the number in front of the X. Awesome. So for the end of the first page, I got a little joke for you. Why are parallel lines so lonely? Because parallel lines never meet. Okay, let's keep on going. Now let's talk about perpendicular. Let's move this down a bit. Let's graph it. So again, we start, we do the slope. So the start is 1. And now again, we go over 4. 1, 2, 3, 4. And up 3. 1, 2, 3. Now we draw a straight line. And take your time on this, because the better your diagram, just the better your quality is. Now this one, look, we've got some weird things happening. So first of all, the start is -2. And your slope is -4/3. And remember, you don't put negative to both, you put the negative to one. So I'm gonna put the negative over to the 4, and that is the up part, and that is the right. So we're gonna go -2, 1, 2, and now we go to the right 3, 1, 2, 3, and down 4, 1, 2, 3, 4, bam. So look at that. Well, these lines are parallel. Just like in the last page, they were, sorry, in the last page was parallel, these are perpendicular. Perpendicular, I can't even spell that. Perpendicular. So look at that, that's a perfect 90-degree corner. So, let's take a look at the slope. Do you see a pattern? Maybe. Let's see if it happens here. Here we're gonna graph -2/5x plus 1. So we do the start. We go, oh, let's take a look at this, and let's make it -2/5. So we go to the right 5, 1, 2, 3, 4, 5, down 2, 1, 2. That's our first line. Our next line is at -3, 1, 2, 3. And now we go over 2, 1, 2, up 5. 1, 2, 3, 4, 5, bam. Wow. So given these lines are perpendicular, what can we say about the slope? Well, let's look at the first one. The first one, 3/4, and it's not equal to, it becomes -4/3. Oh. Let's look at number 2. -2/5 becomes 5/2. So you see what happens? It became a negative and negative, and it flipped. So that's the key thing. When you've got a perpendicular line, their slopes are negative reciprocals. A very complex word for meaning, flip it and make it negative. So there you go. That is the main point of our lesson. Parallel slopes are the same, perpendicular slopes, negative reciprocal. Let's get a bit more practice now. So which of these equations are perpendicular? So again, we're looking for the flip negative. Let's take a look at 2/3. 2/3 becomes, well, flip it first, 3/2 negative. Let's see, 3/2 negative, there it is, bam. So A and D are perpendicular. Let's look at this next one, C. -4/7 becomes 7/4. Negative disappears. Ah, there it is over there. So we've got C and H. Okay, E is 0.5. How do you flip that? I know what we can do. We can make it into a fraction. So then when we flip it, it becomes 2/1 and negative. So do we have a -2 anywhere? Hey, right there, right there. So these are perpendicular. Let's pause. 0.5 becomes a half. To find the perpendicular, You flip it, the 2 goes on the top, the 1 on the bottom, and make it negative. We can simplify that to -2. So E and G are perpendicular. And the last ones, B is -5. Well, when we flip that, we're like, hey, flip that, put it over 1. That becomes 1 over -5. You punch that into your calculator. Oh, negative's gone. It becomes 0.2. So be careful with the fractions because we can see them as decimals. But if we go back over here, there we go, B and F. Wow, all of those lines are perpendicular. So let's make a summary statement here. We're going to say parallel lines have the same slope. I want you to list them here. Down here, perpendicular lines have the flip and the negative. Yeah, we could say negative reciprocal. So I'm going to leave that for you to practice. I want you to hit pause, practice on those. I'm going to give you a solution set a little later on. What I also want to do now is let's give you a few more question types. What if we change the question so I don't give you the line, I give you 2 points on the line? And you're like, that's exactly it. We got to figure out how to do that. So this first line, -2, 1, 3, 4. Draw a straight line. Next one is 0, -2, 5, 1. 1, 2, 3, 4, 5, 1. So, are A and B parallel? Well, they sure do look it. They look it. But what's our proof? Like, what if I draw it poorly and I say no? The proof is what we just had on the last page. Find the slope. So 1, 2, 3, 4, 5. 1, 2, 3. So that line has a slope of 3 over 5. Remember, it's the rise over the run. Well, let's do the same thing for the next question. 1, 2, 3, 4, 5. Going up, 1, 2, 3. You betcha. The slope is 3 over 5. So because they have the same slope, so line A slope equals 3 over 5 equals line B's slope, which also is 3 over 5. So yes, they are parallel. I'd like to give you the second question to do on your own. That'll be your practice. Let's do one more question. This one here. Can we check if lines are perpendicular? Well, -2, 1, 3, 4. Hey, this is the same as last one. We start the same. 0 -2. 3 -7. 1, 2, 3 -7 is there. So it looks perpendicular. It looks it. But what is your proof? Well, let's do the exact same thing we did for the last question. We know the slope here, 2, 3, 4, 5, is 5 of a run, 3 of a rise. So the slope is 3 over 5. Well, let's check the perpendicular, this other line. 1, 2, 3, 4, 5. It's going down, -5. 1, 2, 3. So the slope there is -5 over 3. So we do have negative reciprocals. Yes, negative reciprocal. Those are perpendiculars. Yes, perpendicular. Please do the rest of this booklet for practice. I'll try and give you some answer keys. So you've got 1 page, 2 page. Thanks very much.